if I also, what would be another great thing to graph on this? And also, should I change the window a little bit? How about we change it to -2 to 2? The x scale, let's make it pi sure, and the y min is -2 to 2. We can see the curve a little better here. What might be another great line to draw if we wanted to understand the relationship between these two functions? What's another great line for us to draw if we wanted to understand? Y equals x. Where should that be? Where should that be? Right there. So if I graph this, it should be a reflection across that line. Does everybody kind of see the picture right there? So if I graph it too steep, before when I graphed this, I took sine and made it too steep. It looked like it went under. It does not. Okay. So there's another way to look at it, which is right here. Great. So now, do we have a limited... So we know that the domain of sine inverse is what? X is between +1 and? So therefore, for this function right here, what has to be true? 1 over x has to be between 1 and... What do we multiply everything by? we need to find a domain, right?
Multiply by x squared.
Do we want to multiply by x squared? Well, we want to find the domain. We want to find out what x should be. Right now we know what 1 over x should be. Might you be tempted to write x should therefore be between 1 and... But is that true?
No.
Because what happens if you put a fraction in for x right here on the... Sorry, what happens when you put 1/2 into there? What happens? It makes it 2, which is not inside there. Okay, so how do we go about doing this? This is just inequality math, which can get pretty tricky. Has to be bigger than 1 for that to be less than 1. Now, what do you have to do to be greater than -1? X has to be less than -1. Does that make sense, everybody? Like, what's 1 over -2? What? -1/2. And is that inside this inequality?
Yes.
Yeah. Asking yourself, where is that less than 1 and where is that greater than -1? What's that line right there? Y equals 1. What's this line right here? Y equals -1. So the question is, where is it less than it? Right here and right there. So you need to find the corresponding x value, right? So you need to find these x values and these x values. Well, when y is 1, what does x equal? This is x equals 1. And what's this right here? X equals -1. So do you see why visually that makes sense?
Yeah.
Okay. So we think there are no intercepts. Is that possible?
Yeah.
We think that's possible. Okay. So what do you want to figure out next?
Symmetry.
Symmetry? What do you think about symmetry on this thing?
Yeah.
Y equals sine inverse of 1 over x. So what do you do to test for symmetry? What do you plug in for x? F of -x, what do you end up with? Sine inverse of 1 over that right there. And the question is, do you remember your sine inverse rules or rules for sine? It is it symmetric about the origin. So this actually equals negative sine of 1 over x, which is equal to negative f of x. So what kind of symmetry does this have? Symmetry across the what? The origin. So what kind of function is that? You said it, Fawn. It's an odd function. Let's do asymptotes. So if we're going to do the limit as x goes to infinity of sine inverse of 1 over x, what's that going to be? That's going to go towards what? It's going to go towards the sine inverse of 0. It's going to get really, really close to sine inverse of 0. What does sine inverse of 0 mean? So sine inverse of 0 equals something, some a value. What does that mean? Can someone explain to me what that means? It means that
0 is the sine of a.
Sine of a has to equal what?
0.
0. So what does a have to be? 0. So this gets infinitely close to 0 as x goes to infinity. So what does that tell us? What's going to happen then? Why are we looking at this? What category are we in? Asymptotes. What kind of asymptote is there?
Horizontal.
There's a horizontal asymptote where? Horizontal asymptote at? Horizontal asymptote, sorry. Back on. 1 over the square root of 1 over the square root of what?
1 minus x.
Not 1 minus x squared in this case. 1 over x squared, because it's not x, it's 1 over x. And then what do I multiply by on the outside? What do I multiply by on the outside? What rule do we have to apply? Chain rule. So it's going to be negative x to the negative 2. Exactly. Very nice. So you have y prime is equal to 1 over, or negative 1 over, x squared times 1 minus 1 over x squared. So we're interested in figuring out when is this positive and when is this negative. When positive, when negative. That's what we're always negative. Always negative. That's kind of cool. Yeah, simplify a little bit. So y prime is going to be equal to negative what? X squared times what? 1 minus x to the what power? Negative 2. Is that correct? Yeah? To the what power? To the 1/2, all to the what power? What did I do? I mean, I tried to flatten it out. Did that necessarily help us too much?
Could you put, or, oh, wait, no, never mind.
I mean, did I flatten that out correctly? What do you think? I dropped the negative 1, chainception, yeah. Negative 1 to the front, so what does it become? Positive, at least, so positive of this to the what power? But then what do we have to multiply by? The derivative of the inside. And what do we have to use to do the derivative of the inside? Product rule. 2x times 1 minus x to the negative 2 to the 1/2 plus x squared. Now you have to do the derivative of that thing, right? What is it? 1/2, 1 minus x to the negative 2 to the what power? Negative half, yes, yes. And then what do you have to multiply by what? Times what? 2x to the negative 3. And then we close the parenthesis there, close the parenthesis there, and then do a. So this right here is where you go, aww. Again, though, we have this second derivative. Why are we looking at the second derivative? Because we're trying to figure out where it's what? When it's positive, and when is it negative, right? Is that correct? Let's just take a look at this for 1 second, okay? Let's take a look at this for 1 second. Do you see any other way of doing the derivative of this? No. It's going to look ugly, right? You could do it without flattening, but if you don't flatten this, what rule do you have to use on this one? You have to use the quotient rule, right? Inside the quotient rule, you have to use the chain rule, right? It's still going to be ugly. Do you agree? So what the book answer sheet does is it just does this. Y double prime is equal to, you ready for it? Ready for it? X times 2x squared minus 1 all over x to the 4th minus x squared to the 3/2 power. This function, we know it's symmetric over the, so if it stops right here, what's that point right there? Pi over 2, right? And it's going to stop right here. What is that going to be? And we know it has to be concave up right here, and we know it has to be concave down right here. So why was this one annoying? 1, there's not that many interesting things about it. 2, it doesn't have any intercepts whatsoever. 3, the derivative is nasty. 4, the second derivative is awful. And what do you have to do to the second derivative in order to find out anything interesting about it? When I see that, yeah, cheat, exactly. Cheat. That's fine for now, because why are we doing these questions? Why do I like these questions? It makes you think about what? Can you guys be more specific? Doing this question, look at how many different types of things related to calculus do we have to be good at in order to do this question? Algebra, trig, but specifically for calculus, we have to know how to take derivatives. We need to know how to derive meaning from derivative, from second derivative. Theoretically, if we had done this without any cheating whatsoever, which is fine, in my multi-class, I call this step right here magic. Sometimes we get to something and it's so awful that we think we did it wrong, so we check our answer, and guess what? We did it totally right, and the book is like, ha ha, here's the simplified version, right? And it's really hard to see. So this magical step, so it's hard because there's algebra in it, but I like these questions because it forces you to do so many different things inside the world of calculus. So many different types of things. Basically, almost everything we've learned in calculus is here. Almost everything. to rates of change. That's what we've looked at so far. We've analyzed graphs, but we've looked at it strictly from the perspective of rates of change. We found first derivatives to find out where a function is increasing and decreasing. We found second derivatives to find out where the second derivative changes sign, to find points of inflection. But we've looked at it from the point of view of studying rates of change. We've started with a position function, and we figured out the velocity function. We have a velocity function, so we could find the acceleration function. What happens, though, if you have the velocity function? You might want to find the position function. If you have the acceleration, you might want to find the velocity. We've looked at it in this direction, position. And in physics, therefore in this class, what letter do we usually use for position? Do you remember? It's S. S. We use that to find V, and we use that to find A. What are we now looking at? Going from A to V and from V to... We're going in the other direction. This is not as hard as it sounds, and there are many different things we have to learn to be good at this. And I will tell you the first thing is it's just going to take practice. Lowercase f. This is the important. In each case, we are finding antiderivatives. Antiderivatives, the opposite. So here's a nice, simple one. If I gave you the function 2x, I said this is the derivative of some function. Derivative. I can almost spell. What function has a derivative 2x? Can you give me one function?
X squared.
X squared. So our capital F is this, and our lowercase f is this. And one way of saying lowercase f is f prime. That's what it equals. What about 3x? Can you give me a function whose derivative is 3x?
3 over 2x squared.
Ah, 3 over 2x squared. Take a look at that. If you take the derivative of 3 over 2x squared, you drop the 2 to the front. What happens to the 3 over 2? What does it turn into?
3.
And what does the power turn into?
1.
1. You're doing these things backwards. Absolutely. Does it get a little bit more complicated?
Yeah.
Sure, let's make it a little bit more complicated. How about 2x to the 3/7? Take a minute, see if you can. Reciprocal. A over b times b over a is equal to 1, leaving you with just the 2. So what would the simplified answer to this be? 7 over 5x to the 10 over 7th. Ah, it's the same thing. Okay, so that's one important thing to know. I'll ask you this again, though. Let's go back to this one, 2x. Can you give me a different function whose derivative is 2x? Can you give me another function? X squared plus anything you want, any constant you want. Because what's the derivative of a constant? 0. So when the question sometimes will be find the general antiderivative. Sometimes the question will be find an antiderivative. Find one. This right here is called the general antiderivative. The general antiderivative, because it represents all of the functions whose derivative is equal to the derivative of what is sine?
Cosine.
Cosine? Negative cosine x. The derivative of cosine is negative sine. So if you want it to be positive, what do you have to put there? Okay. What about b? What's the antiderivative? The derivative of what? What? How do you know that? What have I told you before? What do you know? You've done this before. You know the derivative of ln x is what? 1 over x. So the antiderivative of 1 over x is what? Is ln x. You said it right. You said it right. It is f of x is equal to ln x. But I want to point this one out because you have to be very careful on this one. This is important. F of x is equal to 1 over x is the same thing as x to the what power? Negative 1. Right? What we just did, if I told you to find the antiderivative, what we just did was change the power. We incremented up by 1, right? What happens if you make this go up by 1?
0.
Is that a problem? Yes, because x to the 0 is going to be what? No matter what else you do, right? Is that a problem? So sometimes if you're cruising along, oh, the antiderivative of x to the negative 1 is x to the 0. Is that true? No, it's not. You just need to remember this right here. That was very good that you remembered it, but you knew that because we did that before. We did the opposite direction, right? We've used, I've told you the derivative of ln is 1 over x. So what's the antiderivative of 1 over x? And if we wanted to make these the general antiderivatives, what do we add to each of them? C. What about this one right here? What's the power going to have to be? X to the what?
N plus 1.
You add 1, right? What's going to have to go out front? If you want to cancel n plus 1,
Over N.
what?
1 over n.
1 over what?
N.
No, close.
Plus 1.
N plus 1. Because what are you dropping to the front?
N plus 1.
You're dropping n plus 1 to the front. It has to cancel. And then what do I add to this? Plus c. Okay, so this is what I'd like you to try to do. Try to do this one by yourself right here. Do that one right there. Do that one right there. Do this one. See if you can do it all. Can someone tell me what I should do first? Ah, so you did, I like this, 2x to the 5th over x minus the square root of x over x. Nicole, is that right? Is that what you mean?
Yeah.
Yeah. One way of saying that is simplify. So what does that become? 2x to the minus x to the negative a half. Now is it a lot easier to anti-differentiate? It's much easier now. What does that anti-differentiate to? X to the 5th, right? But what has to go out front now? So 2 over, because you want the 2 to be there. And what does this become? You know it's going to be x to the 1/2, right? So it's going to have to be negative 2x to the 1/2 plus c. Done. This is the example that is supposed to help you understand. Don't forget to simplify. Don't forget to simplify. It's kind of like when you saw a quotient and I asked you to take the derivative. Do you always have to use the quotient rule to find the derivative of a quotient? No. Can you sometimes simplify or rewrite it and make it product, power chain, something like that? Yeah, absolutely. Trying to find the function itself. What do they give us? Do they give us the first derivative?
You have the second one.
They give us the second derivative. Okay, let's look at the second derivative here. If that's the second derivative, can you tell me what the first derivative is? Can someone tell me what it is? It's going to be x to the what power? 3, right? 4x to the 3rd plus, we know it's x squared, so what has to go out front? 3 minus 4x plus c. Okay, that's nice. But the c, what value could the c be? Anything, right? But what do they tell us? Oh, c could be anything. Well, let's just keep on going. Do they tell us anything about the derivative with these two?
No.
Doesn't tell us anything. Let's keep on anti-differentiating.
Has to be 4.
Well, hold on. Let's go back one more. Let's anti-differentiate again. What does fx going to be? It's going to be x to the... Oh, that's kind of nice, isn't it? Plus x to the 3rd. Hey, that's nice. Minus x squared, but what do you have to put out front? What's the anti-differentiation of c? We're going to have a multiple... I'm going to call it c1, okay? So it's going to be c1x plus... This is the function, right? But what's the problem? What do we want to know the values of? C1 and C2. Well, look what it tells us. This is where we can use this right here. When you plug in 0 for x, what is y? 4. So take this and plug it in, and what do you get? 4 is equal to 0 plus 0 minus 0 plus 0 plus... So what does C2 equal? 4, because it equals 4. Sorry, no. You'll do that a lot. You'll be plugging in zeros, and you're like, 0, 0, 0, fish, what? No, I have no idea what's going on. So what do we... When you do this, stop and just write out the whole thing that you know. So what do we now know? F of x is equal to x to the 4th plus x cubed minus plus c1x plus what? Ah! We're stuck. We can't find C1. What haven't we used yet? F of 1 is 1. Is it really nice that they gave us nice values like 1 and 0? Is that nice? Yes. I mean, if I said, plug in 27, would that be kind of annoying? What would you have to use if I said plug in 27? Yeah. So it says F of 1 is what? 1. So 1 is equal to 1 plus 1 minus 2 plus C1x plus 4. That cancels with that. Right? The 1's cancel, so what do you end up with? Negative 3 is equal to C1x. So what does x equal? Oh, sorry, times. The x is gone. I'm sorry. So what does C1 equal? Negative 3? So what's the final answer to this? The final answer. F of x is equal to x to the 4th plus minus 2x squared minus 3x plus 4. There it is right there. If they gave us a second derivative, we better have two other pieces of information. When you start anti-differentiating, one trap you can get into, if you call this C and this C, it's not the same C value, right? It could be different values, right? So be careful. So if you have multiple constants, call it C1 and C2 and C3. Or could you call it C and D and E and F? Yeah. Absolutely. Who has an answer to 71 that they'd like to share? Who has an answer to 71 that they'd like to share? Who has it? Biggie, what do you get? F of x is equal to what?
1/2 x squared
1/2 x squared, okay.
minus x cubed
Yep.
plus 4x.
Who got that? Who agrees?
We have more.
Well,
There should be. Plus what?
Oh, plus.
Plus what?
2x plus 1.
Who has that? Generally speaking, is that how I want their answer written?
No.
No. I would like it written as 4x to the 4th minus x cubed plus 1/2 x squared plus 2x plus 1. I want it in descending order. 70, what do you do first? What do you do first?
Oh, wait.
Simplify. U plus u to the negative 1/2. So if you do the antiderivative, you do the general one, what's that going to be? 1/2 u to the minus, or plus what? Plus what? 2u to the what power? Kids, hi.
1/2.
Hi. To the what power?
1.
1/2 plus what?
C.
Plus c. To finish this, we need the value of c. But what do they tell us specifically? They tell us that f of 1 is 3. So what can you set up? Tell me what line I can write. 3 equals 1/2 1 squared plus 2 times 1 to the 1/2 plus. So 3 is equal to 1/2 plus 2 plus c. So what does c equal? What does c equal? 1/2. So your final answer is f of u is equal to 1/2 u squared plus 2u to the 1/2. What?
Oh, wait, no.
No, it's plus positive 1/2. So there is your final answer right there.